Do you remember that XNA framework had divided all its code into different namespaces that were nested inside each other? Well, that's because they have so many classes that they wouldn't be able to keep track of them if they were all in the same folder. So let's do the same thing for us. Right now we don't have so many classes, so much code, but maybe we'll get some more later, and then it's good to put it up already. So let's add a new folder, and let's call that graphics. And remember that a folder is similar to a namespace, so this will be our graphics namespace. And then inside this folder, we will add a new class. Today we'll make an image class. We will make a class, a piece of code that will take care of displaying an image on the screen. Because if you, I can close that. If you remember, right now we display things inside the engine. So if we want to draw a box, we should probably not do that in the engine because that's supposed to be the overview. So that's just a design decision I'm making to make a new class and put all the graphics code in that one. So I'll add a new item because we're making new code and we're making a new class. You see there are many different kinds here, but we'll just do a class, the normal one. And since this class will deal with images, we'll just call it image. And it is Pascal case, because this is something other programmers might see, or other classes will see if we only have one programmer. So there we got the image file, and then it opened the file for us. I don't think we need the Solution Explorer, so I'll remove that. Every little piece of space counts. Okay, here they have put up some using statements already. That's nice, but we won't use them. Oh, yeah, maybe we will later on, but let's remove them for now, because we can add our own as we go along. It's clearer that way. As you can see, the namespace, since we put it in a folder, the IDE has already added the graphics namespace for us. So that was nice. Now this class will deal with an image. It will draw an image to the screen. And if we want to draw many images, then we instantiate many objects of this class. So how do we draw an image? Well, you remember over in the engine class, I cheated and put it up here. We had the draw method, right? If we go to the main methods and we go down to draw, you have that here. You remember the sprite batch had a draw method that we could pass variables to, and we chose the kind of method where we pass in 3 variables. Well, there is another one. I'll show you. This sprite batch draw. If we go to that one instead, there are so many of them that they even go outside the screen, some of them. First it wants a texture, then it wants a position of the texture, which is a vector2, an x and y coordinate. And then it wants a source rectangle, which is the rectangle to extract from the texture. For example, if you have a texture that is big like this, and it has a ball here, and it has a box here, and it has the player character over here, then we just want to extract this rectangle from the texture and then just paste the box into on the screen. It wants a color, which is basically the tint to put on the box. So if we have a white box and we choose the color blue, then the box becomes blue. Float is the float rotation is a floating point number for the rotation in radians, and then there are some more to it. Some of them are out of the screen, and then you have some effects and layer depth. There are a bunch of different parameters that we will pass into draw. And since the image class will take care of all of this for us, then we might as well make it a bit advanced. So we're going to implement all of these on our class. So I'll go back to image here, and we'll start implementing them one by one. And then when we make the call to draw, then you'll see that the call will be very easy to make. Now the first thing we're going to need is a bunch of fields, a bunch of blocks of data where we can store all these things, such as the position and the rectangle and the color tint and so on. And if let's say like this, all of those fields will contain the data that we pass to the sprite batch. So the first thing we need to know is what sprite batch to pass everything to. So I'll write sprite batch here. We can do it beautiful like that. We need to know what texture to take the image from. The position of the sprite, we need to store where the image will be placed. We need the source rectangle from the texture, the part of the texture to extract. A color for the tint. And then there were rotation as well. Then there were a few that were off the screen for you. Origin is the point which the point on the sprite, which is the placement of the position. I'll show you. For example, if you have a box like this and you choose to make origin here, for example, if position is let's say you have X this way and you have Y this way. Let's say position is 100 pixels in and 100 pixels down, so you have the X there. Since origin is up in this corner, that means that the box will be drawn like this. And this origin also works with the rotation as well. So if we have rotation on this, then it will spin around this point so that the box will be like that instead if we rotate it. Did I mention that it uses radians and not degrees? Well, you'll see that later on. After origin, we are also going to need a scale if we want to make the image bigger or smaller than the default pixel size. We might put some effects on it. This is XNA's word for basically for flipping the sprite, mirroring the sprite horizontally or vertically. So rotation and effects together means you can put the image any which way you want. And then there is a layer, which is basically the same as in Photoshop, that you can put things on different layers so that they are on top or below each other. Then if you haven't used Photoshop, a layer is, if you imagine you have a bunch of transparent overhead sheets, then each sheet has a number, and if you put them on as a stack on top of each other, depending on which one you draw on, then they will be on top of each other. These are the variables that sprite batch will use. So let's start by implementing these. Now I'm going to start using some of the vocabulary that we have gone over. And as I've said before, the vocabulary review in the beginning, it's a quick and dirty way to get you to start to recognize words. And now is the time when you will actually start learning how they are used instead. So the first word we're gonna talk about is encapsulation. The image class is taking care of the image. So the engine doesn't need to know anything about the image. It just tells the image, draw an image, and then that's it. The image will take care of, as you see, it will take care of the rotation and the position and everything else. So if we encapsulate all of this functionality inside the image class, then the engine doesn't need to bother, and the engine will have very clean and nice code. So if another programmer comes in and wants to help on this project, he will be able to do so because it's not a mess. And one way to encapsulate is to hide things that the engine doesn't need to know about. And that was with the private keyword, right? And now we want to make a sprite batch. So then we need to declare a data type. And that was in the that was in Microsoft XNA framework graphics, wasn't it? And then in there you have a sprite batch, right? That's the data type we want. And then we need a name for it. So why not use the sprite batch name we had at the top? We'll use Pascal casing because this is a field and other classes won't see it. And we finish up. That was a lot of typing, right? So let's go up here and make a using statement. We can actually go down here and copy all of that and paste it in up there instead. We will use that namespace, which means we don't need to define it down here. It's enough with sprite batch. I actually don't need to write private either. So it's actually enough to write like that. But for clarity, I'll put private in there. But the default access level is private, so I don't need to put it up there actually. Private texture, the data type and the data type and the label are pretty similar. And then we're going to use a position, right? But that one is in a different namespace. I can show you if we type private and then we type vector 2, right? Vector, we don't have it in the list because we're not using that namespace. Using Microsoft XNA framework. Now we're using that namespace. So if I go back and I type vector 2, then it shows up in the list. Position. And then we have a rectangle, which is called source. As you can see, I'm using a lot of IntelliSense. I just type PR and then space, and then I want a color as well. So I get that and click space. As you can see, this is in the graphics namespace, and we're already using that. So once I get to that point, I'll just click space, and the name of it is color, so I need to type that out. P space, we need a float, FL space, and then rotation. Maybe you're wondering where I'm getting what kind it is. This is a sprite batch, this is a float, what data type it is. I'll show you. I'll just finish typing the list. Private, this is a vector 2 for origin, right? And then we have private vector for the scale, and private sprite effects. It's down there in the list, so I'll click arrow down and then space. We'll label it effects as well. And private float layer. That should be the last one. I'll show you. If we go back to the engine again, and I go over here, hold down Control, K, and P. Then it says here that the texture is of the texture 2D class. Color is of the data type color, or the not the class. The data type is texture 2D, which is a class, so it's gonna make an object. It's gonna be an object that. Data type is rectangle, so you can see through IntelliSense what it is that you need to type when you get over here. Okay, we're pretty finished with that. So we'll close it up. Now here's a small test for you. Which ones of these are value types and which ones of these are reference types? Well, that might not be so easy to answer for you yet. But if you remember some of them, for example, float, you remember from the list that that was a value type, because a float is just 32 bits, so it will be stored right away. There will not be any reference to that one. While, for example, the sprite batch, that is an object that we pack up, so that one should just store a reference, right? Well, we'll get to that in a second. These two are definitely references that we need to get from the engine. And then the other ones we'll handle internally inside the class. Should I mention anything else about the fields? Yeah, maybe I should. The rotation is 0 when it is straight up, as it is in the beginning. Scale is 1 when it is pixel by pixel transferring. And effects is normally none because we don't want to flip it. Layer has to be between 0 and 1. So we'll try to put everything on 5 because then we have some space above and below to put stuff as well. A vector contains 2 floats, right? So the position on the screen can consist of decimal points, which means that we can move an object half a pixel. And well, that's going to be very useful even if it sounds a bit weird in the beginning. The default color that we will use is white because white means that there is no tint. I think I mentioned that before. That should be about it. Okay, let's move on. Let's create some main methods as well. And if you remember, there are a few that XNA uses as their main methods. So we will use the same methods in our classes as well. We might add all of them eventually, but right now we just need to load some graphics. So we will use that load graphics contents, and then we need to initialize all the variables so that they are 0.5 for the layer and the tint should be white and so on. And then we actually need to draw the image. There are, you remember, a few more such as update, for example. But we won't use the update method yet because an image doesn't have much logic to update. It just sits there, right? Let's end the region as well right away, so we can type between these. Okay, let's start with the load graphics content. This one needs to be accessible from from the engine. So we make this one public, unlike all the private fields above. This one doesn't return anything, so we'll make it void. And then we have load graphics content, right? Now, I'm gonna do something funky here. You remember that these two, when we pass them between methods, then it copies the reference. It doesn't copy the actual object. So we don't have, if for example, we make a sprite batch over here in the engine, up here in the load graphics, here we make a new sprite batch, and we store it inside the sprite batch field in this, which means in the engine, right? Okay, so out here we have a sprite batch. Now, if we send that sprite batch as a parameter when we call the load graphics content method in the image class, then it won't make a copy of the entire object. It will just make a copy of the reference of the page number that the object is on. So let's do a sprite batch kind of data type, right? And then we can call it anything we want. This is the name of the parameter, but the naming convention suggests camel case, so we start with a small one, sprite batch. So we declare that variable, and we will do the same thing with the texture 2D. We'll pass that in as well. So we actually create the texture out here when we load it from file out in the engine, and then we just pass a reference to it into the load graphics content. There is a way to explicitly type this just like as you type private. If you want, you can type ref before, which means that this will definitely be a reference. But just like with the private word, this is the default for all objects, and both the sprite batch and the texture, they are objects. So, maybe it's good practice to type ref, but I'm not in the habit of doing that, although I do have a habit to do it with private. So, yeah, well, that's just a quirk that I have. You have your own quirks. I'll make the brackets right away so we have them. This is going to be a little bit confusing, but we have been good, and we have used this keyword a lot. I'll go over to the engine and show you. If we go up a bit, in the engine class, outside any method, just right here in the class, we define the sprite batch field. This means that it has class scope, so it will live as long as the engine lives, and the engine will of course live as long as the game lives. So this sprite batch field will always exist. Then we make a sprite batch object, we instantiate that, and we put it inside this sprite batch. This referred to the instance of this object, right? So the instance of this engine class, which we made over in the program file, will contain the sprite batch field, and that is the one we're assigning to because we're using the keyword this, right? Well, this is important because when we come over to the image class, now we have two different sprite batches, right? We have one up here, and we have one that we declare here as a parameter. So how do we keep them apart? This sprite batch means that we are referring to this one because this was referring to this object, and the one that is temporary, just a parameter, then we don't use the keyword this for that. So when we get the sprite batch from the engine class, we will assign it to the one up here. Uh, so we just do the sprite batch like that. That should be fine. I'll show you. From the engine, we make a method call and send a reference to the sprite batch, store it temporarily in the parameter, which we have down here, and then we assign it to this sprite batch, which actually means that we're sending it up to the memory slot we declared up there. Pretty messy, but this is something that you're gonna do a lot, so you might as well get used to it. In fact, we're gonna do it right away. This texture will assign to that one as well the texture variable, the texture parameter. So we do the same thing from engine. We get the texture, we send the texture, assign it to this texture, which is the one that is up there, twice. Okay, the next one is initialize. Oh, maybe we should have it public and void as well. I'll do all the brackets and things first so that we get it to look pretty. Okay. The way I like to program is that I try to pass as little as possible between engine and image, and or between all my classes. If a class deals with something, then it should deal with it and not get it from somewhere else. So I try to always leave the parameters empty. I think it looks nice and clean. Some other programmers don't do this, and it's basically up to you. I should probably have Pascal case instead of camel case on that one, because this one is public, right? Okay. Scroll down a bit because we're gonna need some space here. We're gonna need to initialize. We're gonna need to set all the fields that we made up here. What we can do actually is we take all of these and we copy them, and then I paste them in there. Now this is not going to work. You see, I get a lot of red lines because it should say this there instead, right? I'll put this in everywhere. We will assign to these right away. That's a good way of initializing them. So I'll just remove these keywords everywhere. Actually, we need to remove private as well. I guess I forgot to do sprite batch at the top. Okay. Now, in load graphics content, we initialized these two guys because when the device is reset, we need to redo them. So they need to be in this separate call, separate method. So I'll remove them from here. But all the other ones we need to initialize. And how do we do that? Well, that's easy. We'll just assign to them like this. And we can assign anything we want. Now, this is called hard coding. So if I, for example, make a new vector, and let's put our box 100 pixels in and 100 pixels down, for example. Now we have initialized the position. Okay, now you're screaming. Remember we were supposed to use the keyword new inside the constructor, and the initialize we just use to set things. For example, if we do the rotation, for example, here we just assign let's not have any rotation as the default value. Now you're screaming, why is there a new here? It should be in the constructor. Well, the vector is not a class. The vector is a structure. we haven't gone over structures yet that are similar to classes, but they are value types instead of reference types, and a few other quirks too. Um, so uh, as I said, this is an overview. There are going to be a lot of things that you're going to learn later on as well. Um, source. That was going to be a rectangle, right? New rectangle. I'll show you in the list. It even says struct here for structures. It's not a class. Uh, let's do that rectangle. And the rectangle wants the x coordinate, and then it wants the y coordinate and width and height. So let's give it that. Uh, in our box texture that we're using, the entire texture is the box, right? So we need to give it the 0 and 0 for the x and y, because we're going to start up in the corner and get the whole texture. So we need to do the width and height as well. So what were the width and height of it? They were 128 and 128, right? Yeah, I'm pretty sure. Now you're gonna scream again because we are hard coding these numbers. We are hard coding 100, 100, and 128. What if we change the size of the box image? Then this is not gonna work anymore. Well, the entire code that we are making today is just temporary. Eventually we will read all of this from an XML file instead. So we can type that in. And as we read this from the XML file, then we'll assign to the position. So we would put this inside the XML file instead. But right now we'll just hard code it into the code here instead, and we'll fix it later. It's a bit cheating, but we can't do everything at the same time. We were gonna have the default color color. Where did it go? There's the XNA structure. You can watch this a bit. I did wrong. I used the color field that we have declared in this class, but we should have the structure from XNA instead. So if I click period there instead, and then I get white down there, that's going to be the default one. And for origin, we'll do a vector again. How about we use half the width and height of the rectangle that we just declared. So if we type source and we get the width from this one and we divide it by 2, and we get source and we have height, and we divide that by 2 as well. Then we should get the center of the image as the origin, as the pivot point for rotations and the placement. That sounds pretty good. The scale, as I said, if it's 1, then it is going to be pixel per pixel, just copying and pasting. The vector 2 structure actually has a tiny little thing down here. It has 2 of them actually. I'll show you. It has 1 returns a vector 2 with both of its components set to 1, and it has 0 if you want to return 0. So we'll just use that 1 to automatically set the scale to full scale. The reason why it is a vector 2 is because you can have different scales on the x and y, on the horizontal and vertical alignments. You can have them, you can have it stretched, so it's a very long box, for example. As for effects, we don't want to have any effects. Oh, it actually suggests sprite effects right away, so I'll do sprite effects. This one also has one of those fields for none. If we want, we could flip vertically or horizontally instead, but we'll just do none. And as I said before, we'll try to stick in the middle for now, because then we can add things below and above later on. Okay, that is a pretty nice and clean initialize method. So let's go to the last. Let's make this public too, so we can call it from the engine. Void doesn't return anything, and draw. Now, as I said before, I try to pass in as little as possible, but I can't pass in nothing, because the code inside here might later on want to use the time. As the time changes, the update method might and the draw method might not be called with an equal pacing each time. It might be a slightly different time since last time it was called. So then maybe we need to change something. For example, let's say that the draw method has an animation, and Windows just started uh, checking for viruses. The antivirus program kicked in. So the last time the draw was called was half a second ago instead of a 60th of a second ago. That means that the animation should have moved uh, more than if it would have just been a 60th of a second. So that's why we need to pass in the game time. Uh, Luckily there is game time that we can just declare, and then we keep it here. We're not going to use it now, but we might use it later if we make, for example, an animation. So for now we'll just declare it so we can pass it in for future use. Okay, the draw method of the image class is the one that actually draws the image, but we are lazy, so we're just gonna use the draw method that the sprite batch provides. So we'll do the sprite batch slightly outside the screen, but I'll click a full stop, and then we have the draw method there, right? So I'll do a parenthesis, and then we have those 7 things that we need to pass in. We need to pass in a texture, and we have, we have the texture here. So we just pass that along. We have the position here already, so we just pass that along. We have a source. This source, pass that along. We have a color, and we have a rotation. We have an origin. We have a scale. We have an effect, right? This effects, there it is. And we already have a layer. So we'll just pass all of the fields that we made in the beginning to sprite batch draw method when we call it. So the call here, the whole method here will be very clear, very easy to read for other programmers, because the messy stuff is up here instead. And it was just a design decision I made. I defined the fields for all of them, and for all of the things that I was going to pass into draw. That was the basis for designing this image class. So the draw call is really easy to make. I'll just list all of them. Now, I'm deliberately typing private, although I don't need to. I could remove it because I think it's clear for you guys. So I probably should write ref here too, because it's clearer for you guys. But I'm not, so maybe I don't need to write private here either. I'll keep it now. Actually, you don't need to type this here either. It works to just write position. The reason why I'm doing this is because you get more robust code if you always type this when you mean this object, the fields on this object, because otherwise you might run into problems that you have a sprite batch parameter. So this is the parameter, this is the field. And if you always type this, then it's very clear. If you would do like this, that would be really screwy. Um, so there is a reason why I type so much of the things that are default. Um, you will have less problems later on. Okay, let's fix up a few things in the engine class and then we should be done. Okay. Um, one thing I should probably mention before we leave. We made this in the graphics namespace, right? Our game has a nested namespace called graphics. So the first thing we need to do over in the engine class is tell the program that we're gonna use that. I'll show you. Uh, let's make allocate memory. We allocate memory here, right? Um, let's allocate memory using this image class. So if I go down here and then I type image, it's not in the list for IntelliSense because even though it's our own namespace, since it's a nested namespace inside our original one, then we need to have a using statement for it. So now you see, now it changed color to image there, right? Okay. Let's create allocate memory and then create an instance of our image class. Let's call it box because that's what it's going to show. It's going to show a box. Now the image class is going to take care of everything for us. So we no longer need, oh, I already removed it, sorry. There used to be a vector2 sprite position here, right? Remember? We did that in the previous video. Um, we don't no longer need that one. Sorry, I had already removed it, but let's remove it now again. Because that's going to be taken care of by the image class. Down when we instantiate in the constructor, is that a good idea perhaps? This box needs to be assigned to. We need to make a new image. And we didn't make a constructor in the image class, but C# provides a default constructor for us that doesn't take any parameters. So we'll just use that one instead, like that. Okay. Over in initialize, scroll down a bit more. I'll hold on Control and click MM. Get it to open up here. We don't need to initialize the sprite position anymore because that's going to be taken care of by the image class. So the code in here is going to be much cleaner than before. So now we just need to initialize our box. Down there we have initialize. And this one didn't take any variables because the image class takes care of itself. Load graphics, we're gonna need to muck about with a bit. This is gonna be a little bit messier. I'll show you. This box, which is the object, will want in its load graphics content method, it wants the sprite batch and the texture. Remember that these were references. So if we pass in this sprite batch, for example, and we pass in this texture, Oh, sorry, we called it my texture in the beginning, like that. Now, this is a bit messy, but what's going on is that we have a field containing allocated for the sprite batch. We pack up the sprite batch object and put it inside there. Then when we pass it to the box, then this will just be a reference. So they will actually, this sprite batch and the sprite batch that is going to be inside here, inside the box object, they're going to be the same object, but they have each got a reference to the right page in memory. Uh, if this would have been another programming language, then we would have to keep track of this, that we have here we have one reference, there we have another reference, and when we are, let's say we delete the box object from memory, then we delete this reference, but we still have that one, so we can't clean up the class, we can't clean up the memory yet, because there's still a reference to that memory. And stuff like that. It's really messy with some programming languages, but with C#, you don't need to worry because you just pass references to anything you want, and whenever they're all gone, then C# will delete the actual object that you created here with the new keyword. It will delete by itself. We're gonna use that in a little while to do some funky stuff. But maybe we don't get to that today. I'll scroll down to draw. Now this will also change. Let's move that up and move that down like that, because the box will take care of drawing itself, right? So we don't need to draw anything out here. All we need to do is call the box method draw. This one wants the game time, right? And we already have that as a parameter in both update and draw. So we can just pass that in here as well. Game time, and that's it. Much cleaner than before, right? This makes it easy to later on, if we want to add another box, then this piece of code will be very clean if we have several boxes, compared if we're going to have to keep track of like before we had sprite position out here in the engine class, and then we have to call sprite batch and pass in this the sprite position and so on. Now we don't have to do anything, we just call draw and the image class will take care of everything. So even if we have several objects, the code doesn't get bigger here. You'll see that later on. I'll hit F6. Try to compile, but there's something missing here. Oh, there should be an equal sign there, right? I'll hit F6 again. And then we have something else. Oh, we forgot the F there, right? I'll hit F6 again. Build succeeded. Sounds much better. I'll hit F5 too, and then we see if we get that box. Yeah, we did. Good. Nothing really changed. We still have the box in the same place, but now we have much cleaner code because everything is in its own class. So I'll delete that. Let's get back to a little bit of theory, and then we can actually do something with this image class so we get some use out of it instead of just adding a lot of clean code.